Hello friends, welcome to EC Academy. In this lecture, let us understand Karnaugh Map, which is K-map. K-map is the graphical representation which is used to simplify the Boolean expression. So K-map is the graphical representation that is used to simplify the Boolean equation or Boolean expression. So for a Boolean expression consisting of n variables, the number of cells required in K-map is 2 to the power of n. So the number of cells that are required in a K-map is 2 to the power of n. So here n represents number of variables in a Boolean equation. For example, if we are having two variables, then we can have 2 to the power of 2, which is equal to 4 cells in a K-map. If we are having 3 variables, then the number of cells required is 2 to the power of 3, which is equal to 8 cells. If we are having 4 variables, then the number of cells required in K-map is 2 to the power of 4, which is equal to 16 cells. Here, the K-map is based on 3 types of inputs, which are 0, 1, and don't care. Here, don't care can be represented by X or D. So, K-map is based on 3 types of input, which is 0, 1, and don't care. So, here don't care is usually represented by X or it is represented by D. Now, if we are having 2 variables in a Boolean expression, let us understand how to write a K-map. This is the representation of K-map for 2 variables. Since we are having 2 variables, we will be having 4 cells and we can write A here and we can write B. Corresponding to A, we can write 0 and 1, and corresponding to B, we can write 0 and 1. Now, each cell will be having the number based on the value. For example, if A is 0 and B is 0, so this cell will be having the value as 0 because 0, 0 is 0. If it is 0, 1, so it is 1. If it is 1, 0, the corresponding cell will be 2. And if it is 1, 1, the cell value will be equal to 3. So this you need to remember so that you can simplify any given Boolean expression with 2 variables. So if we are having 2 variables, we will be having 4 cells in the K-map. If we are having 3 variables, so the K-map will be having 8 cells, and this is the representation of K-map for 3 variables. So we can write A here and then we can write B and C. Corresponding to A, we can write 0 and 1, and corresponding to B and C, we can write 0, 0, 0, 1, and next we need to write 1, 1 in place of 1, 0, and then we need to write 1, 0. So this you need to remember. So first you need to write 0, 0, then 0, 1, then 1, 1, and 1, 0. So corresponding to these values, we can write the value of these cells. So 0, 0, 0 corresponds to 0, 0, 0, 1 corresponds to 1, 0, 1, 1 corresponds to 3, and 0, 1, 0, it will be 2. Similarly, we have written 4 because 1, 0, 0 represents 4, then it is 5 because 1, 0, 1 is 5, then 1, 1, 1 is 7, and 1, 1, 0 is 6. So remember this K-map so that you can easily solve the problems. Now if we are having 4 variables in Boolean expression, we can have total 16 cell in K-map. So this is the representation of K-map for 4 variables. So it consists of 16 cells from 0 to 15. So here we can write AB. Corresponding to AB, we can write 0, 0, 0, 1, 1, 1, and 1, 0. And corresponding to CD, we can write 0, 0, 0, 1, 1, 1 and 1, 0. Again, here you need to remember after 0, 1, we need to write 1, 1, then we need to write 1, 0. And similarly here, after 0, 1, we need to write 1, 1 and then it should be 1, 0. So correspondingly, we have written the cell number. So this is 0, 1, then 2, 3, 4, 5, 6, 7. Then here it is 8, 9, 10, 11 and 12, 13, 14 and 15. So this you need to remember so that you can solve the problems. Now let us understand some of the rules to solve K-map. The first rule is we can either group zeros with zeros or ones with 1. We cannot group zeros and ones. Once we have entered the values in K-map, either it can be 1 or zeros, we can group zeros with zeros or we can group ones with ones. We cannot group zeros and ones together. So you can group either zeros or zeros when you are considering product of some Boolean expression, or you can group ones with 1 when you are considering sum of product expressions. So you cannot group the zeros and ones together. Don't care can be grouped with zeros and ones. So don't care can be grouped with zeros as well as ones. And this don't care cannot be grouped separately. So whenever you are making the group, you can group don't care with zeros and ones. So you cannot group don't care separately. So we can ignore don't care when all zeros and ones are covered. Next rule states that the different groups may overlap each other. So here the different groups can overlap with each other. Each group must consist of 2 to the power of n, which means we can group as 1, 2, 4, 8, 16 and so on. So we can group either a single variable or we can group as 2 or we can group as 4 or we can make a group of 8 or we can make a group of 16 and so on. The groups can only be horizontal or vertical. It cannot be diagonal. So whenever we are making the group, we can group it in horizontal direction or vertical direction. We cannot group in a diagonal form. So as you can observe here, we are having a diagonal grouping, which is incorrect way of grouping. So if we are having two values like this, we can individually group this. We cannot diagonally group these values. So either we can group horizontal or we can group vertical. We cannot group diagonally. Each group should be as large as possible. So we can make each group as large as possible. So which means we need to observe whether we can group 16 variables first, or we can see whether we can group 8 variables, or we can see whether we can group 4 variables. Then we need to look whether we can group 2 variables, and then we can look whether we can group 1 variable. So we need to always group as large as possible. First we need to observe whether we can group 16, then we need to see we can group 8 variables or 4 variables and so on. So as you can observe here, we are having 4 variables. We can't group this as 2 variable. We can make this as a single group. So we can group as 4 variables, as you can observe here. Similarly, these 2 variables will be left out. So we can group as 4 variables. As you can observe here, we need to group this as 4 variables. And then these 2 ones are left out. So we can group these 2 ones with these 2 1. So we can group this as 4 variable. So this is the correct way of grouping. Opposite grouping and corner grouping are allowed. So you need to remember the opposite grouping and corner grouping is allowed. As you can observe here, in the corners we are having 1. So we cannot group this individually. Since these ones are available at corners, we can group all these ones as a single group of 4 variables, as you can see here. So we can group all these 4 corners and we can make this as single group. So opposite grouping as well as the corner groupings are allowed as shown in this figure. Now let us take few examples. Let us start with 2 variables. So here the function is given with 2 variables whose output will be 1 for 0, 1 and 3. Now let us take the k-map for 2 variables. We are solving this for sum of product Boolean equation. So that's why for a sum of product, wherever the output is 1, correspondingly we will write 1 in the k-map. So the output is 1 for 0, 1 and 3. So at 0, 1 and 3, we will write it as 1. So we can write 1, 1 and 1 corresponding to 0, 1 and 3. So other cells you can enter 0 or you can leave as it is. Now once you enter these values, we can group these to 1 and then we can group these to 1. So we can make these 2 group of 1s and we can make these 2 group of 1s. So for this group represented by blue color, we can write the values of A and B. So for this one, the value of A is 0, the value of B is 0. For the first group, AB value is 0, 0 and the next value for AB is 0 and 1. So we can write 0 and 1. Now you can cancel out the variables which is having different values and you can keep the variables which is having the same value. So for this, what you can do, you can cancel out these value and the value which is left out is A with value 0. So since we are writing in sum of product, so whenever you are getting 0, you need to write the complement of the number. So you will be left out with A dash after simplifying the group represented by blue color. Now if we take the next group, we can write the corresponding value of this one which is 0, 1. So for AB, you can write 0, 1 which is first value. The second value is 1, 1. The second value is 1 and 1. We can cancel out this 0 and 1 because it is having different value and we are left out with B with value as 1. So since 1 is there, we will take the variable as it is. So for 0, you need to take the complement of the variable and for 1, you can write the variable as it is. So we will be left out with B. So the final simplified expression will be A dash plus B. Now let us take an example for 3 variables. So here the function is given as 1, 3, 6 and 7. So which is having 3 variables. So 3 inputs are there, A, B and C. The output will be 1 for 1, 3, 6 and 7. Let us take the k-map for simplifying 3 variables. Let us substitute 1 for 1, 3, 6 and 7. So at 1, 3, 6 and 7 will substitute 1. So here it will be 1, 1, 1 and 1. Now, so we can group these to 1 and these to 1. Let us group these to 1 and let us group these to 1. Now, so corresponding to blue group, so we can write the value as for A it is 0, B it is 0 and for C it is 1. So we can write it as 0, 0, 1. For the next value, we can write it as 0, 1, 1. So you can write 0, 1, 1. Now you can cancel out the variable which is having different value and you can keep the variable which is having the same values. So you can cancel out B and you are left out with A with 0 and C with 1. So since A is having 0, we can take the complement of that variable and since C is having 1, we can write the variable as it is. So we can write A dash C. In the next group, we can write the value for this one, which is 1, 1 and 1 corresponding to A, B and C. So for A, B, C, the first value is 1, 1 and 1. And for the next value, it is 1, 1 and 0. So it is 1, 1 and 0. Since C is having different value, we can cancel out that value and we'll be left out with A and B, which is having the value as 1. So we can cancel out this C and we'll be left out with A, B, because A and B is having the value as 1. So finally, the simplified expression is AB plus A dash C. Since we have simplified this as a sum of product equation. Now let us consider an example for 4 variables. So f of A, B, C, D. So these are the 4 inputs. Output will be 1 for 0, 2, 5, 7, 8, 10, 39, 15. So this is the K-map for 4 variables. So corresponding to these values, we can write 1 here. We are having 1 for 0, 2, 5, 7, 8, 10, 13 and 15. So whenever we are making the group, we need to make the group as large as possible. So which means we can group these to 4. And since these ones are at the corner, we can group these 4 ones in the corner as one single group. Let us first group these middle ones as 4 variables in one group. Then we can group the corner ones as 4 variables in one group. So corresponding to this group, we can write the value for A, B, C and D. For this one, the value will be 0, 1, 0, 1. For this one, the value will be 0, 1, 1, 1. For this one, the value will be 1, 1, 0, 1. And for this one, the value will be 1, 1, 1, 1. So 0, 1, 0, 1, 0, 1, 1, 1. Then we are having 1, 1, 0, 1. Then we are having 1, 1, 1 and 1. As you can observe here, the variable A and the variable C are having different values. So we can cancel out those two and we'll be left out with B with value 1 and D with value of 1. So we can write B, D, since both B and D are having the value as 1. For the next group, we can write the value as 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0 and 1, 0, 1, 0. So we can write for A, B, C, D as 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0 and 1, 0, 1, 0. So if you observe here, A is having different values and C is having different values. We can cancel out these two values. So we will be left out with B with 0 and D with 0. Since B and D are having the value as 0, we can write the complement of those number. We can write B dash, D dash. So finally, the simplified Boolean expression is F is equal to BD plus B dash, D dash. This is about introduction to K-map. Hope you have understood the topic. Thank you.